So here's the backtracking search algorithm to solve a CSP. So this algorithm will receive as input a CSP formalization, which means the domain, the variables, and the constraints, and we return either a solution or a failure. This algorithm will call a function, a recursive function called backtrack, initially with the empty assignment, because we don't have yet assigned any value to variables, and the CSP formalization. All right? So the backtrack function is a recursive, simple recursive function that calls itself at this point here. The function actually will choose one variable at a time in this line here. So it's going to be pick a variable, and we'll try all possible values for that unassigned variable. So for each value in the domain of this value, we are going to try them and see if we can find consistent assignments. If an inconsistent assignment is found, then we are going to try other values, and the algorithm backtracks after removing the value from the variable value assignment from the assignment. So in other words, we're going to, if the assignment is complete and it's consistent, we're going to return the assignment. Otherwise, we're going to pick a variable, pick a value, try it, add that as a possible assignment. If we meet a failure, we are going to backtrack, try other values, and so on and so forth. So this is a simple recursive function. Note here that we are using a general statement for picking a variable, such as select an assigned variable and order the domain value. These are kept general on purpose to implement the heuristics we have seen in this lecture or other heuristics. For example, we could use the minimum remaining values to pick a variable, or the LCV, the least constraining values to pick the values of the domain. That's pretty much it. This is the function. This is doing the search with BTS, and it implements the heuristics we have seen in class. A very popular CSP problem or CSP puzzle is called Sudoku. So many of you probably have played Sudoku before or have seen people playing Sudoku in the train. These are generally puzzles that are printed on newspapers and journals, and the goal of Sudoku is as follows. So you have a grid of 9 by 9 elements, and you want to fill this grid with numbers or with digits between 1 and 9, so as you don't have repetitions between in this element. And these are actually 3 by 3 boxes or rows, columns or rows. So you don't want the digits 1 to 9 to be repeated, and you want all of them to appear in each of these, let's call this units. Okay, so that's the idea of the puzzle. So you need to solve it by filling the grid with digits. Let's formalize this problem as a CSP. So we need first to define what are the variables. To make it easy for us, we're going to give a name to the rows and the columns. For example, this would be row A, row B, until row I. And we're going to give numbers to the columns, column 1, 2, 3, up till 9. So we are defining variables for each of the cells or each of the components of the grid of 9 by 9, which means that we're going to have 9 times 9 equal 81 possible variables defining the Sudoku CSP. Okay, so the variables would be the set V, A1, A9, B1, B9, I1, I9. How about the domain? The domain has to be all digits between 1 and 9. Sorry, there's a typo here. So 0 is not part of the domain. So the domain is 1 through 9 for all the cells that are empty. For the cells that are fixed, such as 3, 7, and 6, these have a specific value. So the domain is simply one single variable. So the domain, for example, for this variable here, which is A8, the domain of A8, has a domain of what? Of one single variable, which is the value 3. So how about the constraints? We're going to express the constraint that says that all 3 by 3 boxes, rows and columns, have different values between 1 and 9. So for example, first we're going to focus on the first row. The first row is the row A1, A2, A3 through A9, and we want all these values to be different. To express that, we're going to use the constraint, an array constraint, which is all diff, that tells that A1, A through A9 are different. Okay, so this constraint will be for this row here. We're going to do that for the 9 rows, right? So it's going to be 9 possible all diff constraints for the rows. We'll do the same for the columns. So for example, for this column here, it has to be that A1, B1 through I1 are different. So again, express that as this constraint here. So it's going to be this set of constraints will be for the rows. And finally, for 3 by 3 boxes, for example, this box here, we need that A1, A2, A3, B1, B2, B3, C1, C2, C3 all be different. So this is going to be expressing that for this box here, we want all these values different. By this specification, we have defined the CSP with variable, variables, domains, and constraints. So how do Sudoku players solve the puzzle? So the idea is to look at the cells and try to fill them little by little. So for example, if we focus on this first row here, we have two missing values, this cell and this cell. What we do in general is to look at the possible values. Since we have all these digits, we are left with the digits 2 and 4 to put, right? So this can take either 2 or 4, and this will take either 2 or 4. We're going to use the constraints of all 3 by 3 boxes must contain 1 to 9. And if we look at this box here, we see that actually number 2 is already taken by this cell here, which is B1. So this value 2 can be put in this cell here. So this will actually help us remove the possible values from this cell here. So this cell can only take the value 4, which remain this cell here with only the possible value of 2. So this cell will be actually 2. So then, given these two values that are set now, we're going to look into the values here. We're going to try to guess what we put in here and in here. So here we know that the remaining values to be put here are actually, we are missing 3 and we are missing 5. However, 3 is already in this row, so this can't be a possibility for this cell here. So the only value that's possible at this point is 5. And we're going to add 3 here because we need to have all the digits between 1 and 9 in this 3 by 3 box. So this is how the Sudokus are being solved. We're going to add digits one at a time by looking into the environment, whether it's within the same row, the same column, or the same block, to see what are the permissible assignment of digits to the variables. So how do humans solve Sudoku in general? So the idea is to try to fill the cells one by one by using those constraints, propagating the information among the cells so as to fill only the permissible values for the variables. So for example, if we focus on this first row here, we see that we are missing 2 values, these 2 values here. The 2 possible values can be either a 2 or a 4, just because we have the values 1, 3, 6, 7, 5, 8, 9, and we only can fill the values, the missing values with the missing variables with the missing 2 digits left. Okay, so we have either the possibility to fill this value here with a 2 or a 4, and same thing here, we can either fill it with a 2 or a 4. But then we are going to use our constraint that says that basically a 3 by 3 box can only have digits between 1 and 9, and there is no repetition. So for example, if we look at this box here, the values here are 1, 2, 6, 8, 9, and 7, which means that we have already a 2. The 2 cannot be a solution for this cell here. So the only remaining value possible for the cell A2 is the value 4. This actually will reduce the domain of the cell A3, 4, 5, 5, A5 to only 2, because actually we already have the 4 in this row here. So we use the information that the values in the row are different, but the values also in this 3 by 3 box must be different. So we keep going. So for example, if we want to fill this value and that value here, we know that we are missing the value 3 and the value 5. Unfortunately, we have a 3 here, so which means that this cell here cannot be 3. The only possible value left is 5, and we are left with a 3 in this box here. So we could keep going with this reasoning until we fill most of the cells, if not all. So it depends a lot on the complexity or the difficulty level of the Sudoku, and some simple ones can just use this kind of techniques to propagate the information among the cells. This is called typically constraint propagation. So you are propagating the information among the cells. So you are propagating the information among the cells to fill them with the digits. But in some fancy Sudokus or difficult Sudokus, it's not enough to use this kind of constraints. And Sudoku players and lovers like to use advanced techniques such that, for example, using the naked double or triple, the locked pair, the locked triple, etc. And the idea of this is simply to make inference on the possible values of the cells. For example, for naked double, we need to find in a 3 by 3 grid 2 cells that have 2 possible remaining values. This will actually help eliminate these 2 values from all the possible assignments in that same box. So by doing so, I'm going to use an advanced thinking or an advanced inference of the possible values for the cells. And these are typically some of the techniques used by Sudoku to solve the puzzle. So just for fun, here's the solution of the Sudoku. So starting from this Sudoku configuration, we need to fill it with these values. And none of these assignments of values to variables actually violates the constraints of the Sudoku.